Hello and welcome everyone to my channel Code with Ease. Today in this session we are going to discuss about this question called majority element. To solve this question we are also going to learn about a very special algorithm called the Boyer-Morse voting algorithm. But we are only going to use this algorithm when we discuss about the optimal way of solving. Before even reaching to the optimal way, we are going to discuss other approaches of solving this question, and then we will see why do we want to use that new algorithm to solve this question. So let us discuss on the problem statement. We are given this array nums of size n and we have to return the majority element. What is a majority element? It is an element that appears more than n by 2 times. And we can assume that the majority element always exists in the array. So as we can see, this is the array 3 to 3 and the majority element is 3 because the size of this array is 3 and 3 by 2 is 1. So any element which appears more than one time is 3 itself. That is why this is the majority element. In the second example, the size of the array is 7. 7 by 2 is 3. So element which appears more than 3 times is 2. Hence the majority element is 2. Hi, here's a brief introduction for the ones who are new to the channel. The objective of Code with Ease is to make problem solving in programming simpler. If you are someone who wants to become a great developer and wants to level up their skills, data structures and algorithms is indispensable and you need to form a solid foundation of that. And this is exactly where we come in. Because we post topic-wise video explanations in Java on various coding interview questions that can not only help to crack the coding interview, but also help to improve and refine the problem solving abilities as a developer. And finally, here is the USP of our channel. We code every solution live, we do not copy paste code snippets. We start off by clearly defining the problem statement, the given inputs, the required output, time and space complexities. We also then discuss the brute force way of solving any question without jumping on to the solution and then gradually move on to the optimal solution. We try to use online whiteboarding wherever applicable to explain the approach and the concepts. So that is all about us. So if you guys also want to be a part of this journey, do support us by subscribing to the channel. So with that, now let's get back to the question. So into the whiteboard, this is the array that I have taken and the majority element is 2 because it has occurred more than n by 2 times. This is the expected time complexity which is linear and the expected space complexity is constant. So first of all, let's talk of the brute force way of solving this. So we know that a majority element is something which has occurred more than n by 2 times. So when we talk of occurrences, we are somewhere trying to track the frequency of an element. So how can I track a frequency of an element? I can use loops. I have to traverse the array, so I'll use a loop. So first thing is to traverse the array. So this outer for loop is going to run from 0 to n minus 1. I also need to track the occurrence of an element. So for that I'll use another loop and inside this loop I'll have the logic to track how many times an element has occurred. So inside this inner loop what I can check is if the current element is equal to the element at the ith index, then count plus plus. This count variable we can take to track the frequency of every element. And then outside the inner for loop, I can just do this simply if the count collected so far is greater than n by 2, then that element means that index or that element whatever, that is the majority element. So in this way, using two loops, we can track how many times an element has occurred. And once we know how many times an element has occurred, we can put a check whether that occurrence, whether that frequency is greater than n by 2, and then we can determine if that is a majority element or not. So as we can understand by now, what is the issue with this approach? The time complexity. We are using two loops, so the exponential time complexity, but our expected time complexity is linear. So we cannot go with this approach. Next, let's try to explore another approach. We can use sorting. If we sort this array, what is going to happen? First of all, it will be 1, 1, followed by all the 2's. How many 2's we have? We have 5 2's. And lastly, we have a 4. After sorting this, if an element has to occur more than n by 2 times, obviously the majority element is always going to be at the middle of the array, no matter what the length of the array is. So what is the middle point of this array? Somewhere here, and this is the majority element itself. So the intuition behind this is majority element, once the array is sorted, will always be in the middle of the array. So once we can sort the array, if we can sort the array using any built-in method, and then we can just simply pick the middle index of the array and return that element. That will give us the majority element. What is the time complexity for this? Order of n log n, which is better than the previous approach, but still not equal to what is our expected time complexity. So then let's move ahead with another approach. What else can we use? We can try to use some space. So in the first approach where we were using this inner for loop, inside this what we were doing is we were tracking the occurrence or the frequency of every element. If we can skip this part, we will optimize our time complexity by just having one for loop. So instead of this, we can use hash map to track the occurrence and the access of the element. Like the retrieval of element from hash map is always order of 1. It's constant. So in that way, we can optimize our time complexity. But the only problem is we have to use space, and our expected space requirement is also constant. We are not supposed to use space, but still we are just trying to better the time complexity. First it was order of n square with 2 loops. Then we are using sorting. It is order of n log n. Now when we are using the space, we can do it in one single loop, one single for loop, but we are using additional space. So finally, here we are with 3 different approaches, but there is a trade-off between time and space. So here comes the new algorithm which we are going to learn, which is called Boyer-Morse voting algorithm. Let's understand the intuition behind using this algorithm. If an element has to occur greater than n by 2 times, then the frequency of this element must be greater than the frequency of other elements combined. What I mean to say is, in this case, what is the frequency of 2? 2 has occurred 5 times. What is the combined frequency of any other elements? 1 has occurred 2 times, 4 has occurred 1 time. Combined frequency is 3. So at any given day, a majority element will always be that element whose frequency is always greater than the combined frequency of rest of the elements across the array. So this is the intuition behind this. And because of this, we will understand how this algorithm works. So first of all, we declare a variable called count. Initially we set this to 1, and we also declare another variable called the majority index to track the index of the potential majority element, and we set this to 0. And then we will use one single for loop which is going to run from 0 to n minus 1. Within this for loop, what we will check is if the current element, let's say the ARR of I, if this element is equal to the element which is pointed by this majority index, I'm just writing MAJ, then we will increment the value of this count by 1. Else we will decrement the value of this count variable. This is the second step. And finally, if the value of this count becomes 0 at any given point in time, we will reset the values of this majority index to whatever the current index is, that is I, and the count will also be reset to 1. Means we're just bringing it back to whatever state it was at the beginning of the array. Now let's try to map our intuition to this. What we said, the frequency of the element should be greater than the frequency of every other element. So here, initially this majority element, this index is also set to 0. And this is actually going to start from the first index, not from 0. So we are just not going to check the element with the element itself, but we are checking the first element with the 0th element. So what is the intuition behind this? If any element has to be a potential majority element, the count of that, the frequency of that element should always be greater than n by 2, like we said. So it potentially should be greater than 1, greater than equal to 1. But the moment it becomes 0 is when we are resetting. Means when we are doing this, we are saying the element whatever it was from the beginning till now, this element is no more a potential majority element. But our potential majority element can be this new element which is at index I. So we are going to continue checking the frequency of that ith element and discard whatever we have collected so far. So that's what, if an element has to be a potential majority element, they must find its matching counterpart, or they must find its multiple copies across the array, hence increment the value of the counter. But if in any case they are not finding its matching counterpart, is when we are slowly trying to decrement the counters till the point when they become 0. When the count becomes 0 means whatever other elements have occurred, they have cancelled out against the frequency of that element. So let's try to understand with an example. Suppose we have element 2 and 2 followed by 3, 4, 5. What is the length of this array? N equal to 5. 5 by 2 is equal to 2. This element 2 has occurred, so count is now equal to 1. Again another 2 has occurred, now count becomes 2. But now I come across another variable which is not equal to 2. So count will become 1. It will decrement. Count minus minus. Again I encounter another variable which is 4. Again the count will become 0. The moment it becomes 0, then the majority element, this everything gets reset. So what is essentially happening is, number of times this element 2 has occurred, it has occurred 2 times. Correspondingly, that many number of times the other two new elements have occurred and they have cancelled it out against each other. But what we told in the intuition, the frequency of that majority element should always be greater than the frequency, the collective frequency of other elements. But in this case, that is not happening. The collective frequency of other elements is 3 and the total element and the total frequency of that element is 2. So 2 is lesser than 3. So it in no way it can be a majority element. So this is the intuition behind this algorithm, that in order to be a potential majority element, it must have its matching counterparts in every places across the array. But if it is not having its matching counterpart, then we have to reset and find another potential majority element. That's it. So now let's see the code implementation for this. So let's start with the code changes. Let's first define the count variable, which is initially going to be 1, and the majority index, which is going to be 0. So within this for loop, now we have to write this logic. First of all, we have to check whether the current element, that is ARR of I, if that is equal to the potential majority element. If that is true, we will increment the value of count. Else, we will decrement the value of count. Just after this, we have to do a check if the count has become equal to 0 after decrementing. If that is the case, then we have to reset the value to 1 of count, and majority index will now be equal to the current elements index, which is I. So now after that is done, finally we have to return the majority element itself, I think. So we'll return nums of, now let's try to run this. We'll submit. Yeah, so that's all about this question, the majority element. Hope you guys have enjoyed the session. Do let us know in the comments below if you guys have any questions or doubts, or you want to share any feedback on this video. If you have enjoyed the session so far, do hit the like button so that this can reach out to many more people. And if it does, it just gives us enough motivation to put out more such content. Also, if you are looking forward to more videos like this, please don't forget to subscribe to the channel and press the bell icon next to the subscribe button to never miss an update on our upcoming videos. Thank you so much for watching.